Hey guys, welcome back. Today we're going to do a couple things. We're going to refactor the inventory component just to start. I've been looking at it a little bit more. There's a couple things I want to do just to touch it up. And then I want to set up the enemy class. I just want to set up a basic enemy class and be able to make an ability that can use our input configuration, and then through the input configuration just deal damage, right? We have health and mana. Let's make an enemy that we can display that we can deal damage to. So first thing is the refactors. If I come back to the inventory and the inventory component, there's two things I want to do in terms of multiplayer. There's not much server verification I could do to add item unless I made the item tag part of a struct with some kind of item ID and got much more into it that I haven't before. But when we talk about use item, there's definitely server verification we can do, because use item again is also just passing the item tag through, which calls server use item. But here, before we just freely use item, if we want to do a server verification, we can just say if inventory tag map dot contains item tag, then we put use item right in between that. So if a client forges an RPC to say use item, and it tries to use mega ultra item and the server inventory doesn't have it, then it won't be able to use ultra mega item because it's not in the server's inventory. So we could do that to try to just safeguard ourselves a little bit. The other thing we could do is in the onrep cache inventory, this reconstruct inventory map, we only really need to do this if the component is locally controlled, really, right? Simulated proxies, like the client, your friend, doesn't need your simulated replicated inventory on your friend's computer. You don't need it there. You need it really only on the server and then on your local machine. So in order to be able to determine if we're locally controlled inside an inventory component, what I could do is come into the header file, and the private section I can just make a boolean and say be owner authority, and I can set that equal to false by default. Oh, excuse me, this can't be a private variable. We need to take this and make this a public variable. So I'll come make bool be owner authority, or excuse me, not owner authority, but owner locally controlled. And we'll set that equal to false, inventory component. So then we could just say if be owner locally controlled, then we can at that point reconstruct the inventory and take the inventory package delegate and broadcast that. To get the value of owner locally controlled, then what we can do is come back to the player controller, which is in game, player controller, and when we're doing inventory set as replicated, but what we could do is in begin play, we could say if is valid inventory components, then we can say inventory component be owner locally controlled equals to is local controller. So then our inventory component will know if we're locally controlled or not, at which point only the real player and the server are going to have the inventory handled. So that's the two things. That's the two things I wanted to start with the inventory component itself. And then the next thing we're going to do is start working on the enemy class. So if we come back into here, come into our C++ classes, now we have this RPG systems character. This is the default character in the project that I've been using. But what I want to do is make a new C++ class, call it character, and this will just be CharacterBase. Make a new folder called character, put that in there. And now that I have CharacterBase, what I need to do is I need to come into, oh, I have music. I forgot. I was going to put music on. We'll put the music on, right? Yeah. What I'm going to do is come into my File Explorer and come into RPG Systems. Oh, that's the wrong one. RPG Systems. And then I'm going to close everything, close my writer, and then I'm going to go into the source, into the, I need to expand the folders like this. Character. So now this is the private, so the system character will move there, and then the public character goes here. So now that I do that, I'm going to reload my whole project. And then after I reload my project, what I'm going to do is open the editor. So I'll see you when the editor opens. All right, so now that we're back in the editor, the whole reason I need to do that is because I need to take this CharacterBase and I need to create a C++ class derived from CharacterBase. And this is going to be called EnemyBase. And we're going to put it in here. So we're going to reparent these. EnemyBase is in here, CharacterBase is right here, and then this is my character. So instead of inheriting from public a character, I'm going to come in here and inherit from a character base, which means I have to include the header. Instead of game framework character, I need to include character base. And then EnemyBase is based off of CharacterBase. Okay, great. Now let's see. Enemy is going to carry, enemy's AI are going to carry the ability system component directly on them. We don't need to worry about putting it on a special class to replicate, etc., etc. You just put it right on there, which means this is going to need to inherit from the ability system interface. All right, so let's look at the reasons we're reparenting this, because we want to share some common functionality. The first thing we want to share that's common functionality is this character tag. So we're going to move this character tag into the character base, into the protected section, so the children classes can have access to it. And then we're going to delete these comments. And we can delete all the rest of this for now. Oops. And then the second thing we're going to want, now that we're back up here, we can actually delete the header, which you want to do inside of a header. If you can clear an unused header out, you always want to do that. So now that we moved it onto the character base, because we're inheriting from character base, I already am going to get that header, but it'll just be, you just get rid of it if it's unused in your header. Second bit of shared functionality that we could do is this function init ability actor info. If we're gonna, we have to do that, right? We have to init ability actor info on everybody to register their ability system component. So if we're gonna do that, then we can come back into the protected section again, and we can make it a virtual function. Virtual init, virtual void init ability actor info. Excuse the typing. And then I can generate a definition that's just intentionally left blank for now. I don't have anything that I want to mutually do for them currently, so the super call is not necessary, or if you do want to call the super call, we could just leave it blank for now. But that means I need to come back into here. This is no longer a private function. This is now a virtual void initability actor override. So now we label it that way. Oh, and our begin play needs to be an override. I don't know why that's not an override. So now that I have that, it'll just register everything the same. But what that will give me is we can start setting up the enemy base. We can come in here and we can say public ability system interface, which included the header, and we can make a public section that is a virtual ability system component, get ability system component. But I need in the first place the T object pointer of the RPG ability system component, which is the RPG ability system comp with the U property. We'll give it blueprint read only meta equals allow private access to true. And then we need the T object pointer of the URPG attribute set for declaration, which is the RPG attributes. With the U property, blueprint read only meta equals allow private access equals to true. And then we need an EnemyBase constructor. And I can generate definitions for both of these. And in the get ability system component, we're just going to return the RPG ability system component, which needs to include the ability system, RPG ability system component. And then in the EnemyBase, I am going to be replicates equals to true to start off with. And then we're going to take the RPG ability system comp and set that equal to create default sub-object of RPG ability system component, which we'll call ability system component. And then we need to take the RPG ability system comp set is replicated to true. And then this is AI, right? So we're going to set the replication mode to the E gameplay effect replication mode minimal. That's what you set your AI to. Save yourself some performance in the replication. And then the last thing we're going to do is the attribute set, just the RPG attributes. And we're going to set that equal to create default sub-object of a URPG attribute set. And this will be called attribute set. Okay. So now I have these and they will be constructed. I need a protected section that I'm going to do a virtual void begin play. We need a begin play and we need a virtual void init ability actor info. Setting this up on the AI is a lot simpler. It is just a lot simpler. So on init ability actor info, we don't need to call super, but we can just say if is valid RPG ability system comp and is valid RPG attributes. If we have them, and we could do that, then we can say the RPG ability system comp init ability actor info, and then the owner actor and the avatar actor is both just this, right? It's just that. So then we say if has authority init ability actor info. But we need to kind of do like the player too. Sharing the character tag so we can use that same data asset to define all these different character classes. So now that we've init the ability actor info, let's create a private function that will say init class defaults. We'll do just like we do. Oh, excuse me, Writer gave me an inline. And it's not what I wanted. What we'll do is say on the init class defaults, we're going to do the same thing we did on the player. If not is if not character tag dot is valid, UE log temp warning text is no character tag selected in this character, and %s with the C get name save this. Then we'll do else if u character class info pointer class info equals to the urpg ability system library get character class default info, passing in this is the world context object, and then we can say if const f character class default info pointer selected class, and then we can set that equal to the class info has the class default info map that we're going to find the character tag. And then we'll say if is valid RPG ability system comp, RPG ability system comp, add character abilities off the selected class. We have the starting abilities, and then RPG ability system comp, add character passive abilities out of the selected class. We have the starting passives, and then we have the RPG ability system component, initialize default attributes off the selected class, has the default attributes. And then what I actually want to do is not say if has authority init ability actor info. What I'll say is just init ability actor info, and then inside here, once I say that, I'll say if has authority here. Init class defaults. That's what I'll do. So the way we have all of our stuff set up right now, this should just be all we need. Let's recompile and open the editor. Okay, now that we're back in the editor, now we have all these things. And we can come back in the blueprints, and I'll make a new folder, and I'll call this enemy. Enemy. And I can make a new folder and call it attributes. And in the attributes, I'll make a new gameplay effect. This will be GE default attributes enemy whatever you want to call it, primary. We're making it for a class, right? So you come up in here and we still do the modifiers of max health first, and we can override to 100 and then health override to 100, and that'll be that. But then we need to come into the data, into the character class info, and we need to add another one. Right now we have a different class to add, which all we have is the character one. So we'll add a character, add a sub tag, and this will be enemy dot primary, right? So we'll add a new tag, character enemy primary, and we don't have any abilities for him, but we could at least give him the default attributes. So now we have that in the data, so I can come into enemy right here, and I can make a folder called primary and make a blueprint based off of EnemyBase. And in the EnemyBase, BP enemy primary. And then in the class defaults, I can say custom values. I need, because I inherit from the EnemyBase, or the base character base, I have the character tag that's still used in all of that. And in the mesh, what do I have? Does this even look good? That's disgusting. We'll use Manny. Now that we have Manny, use an animation blueprint, there should be ABP Manny. And then because it's a mesh, we need to come, the location is -88Z, and the rotation is -90Z. And now it faces, now it's on the ground facing the forward direction of the capsule, lined up. And this has the ability system component and the attribute set on it. So I should be able to, if we want to, let's get rid of these items. And let's drag this guy into here, and we'll flip him around to look at us. And how am I supposed to see what his stats are, right? Let's see. I just play the game. He's right there. How do I see his stats? Well, the easiest way I could do that is just put a health bar over his head, right? So if I come into here and I make a new folder and I call it widgets, and I just make a user interface, a widget blueprint that's just a regular widget, and call it W enemy help, enemy overhead bars. And I'm gonna take a size box. Do I just want to show inside this size box this progress bar, we're just filling it up. I can literally make it 60 wide by 15 tall, because it's just gonna be on top of the character's head. And then in the progress bar, I'll call this health bar, and it is variable, and it fills left to right, and the fill is going to be 1 red and all of that. And then in the style, the background image, the tint is going to be 1 red, but it's going to be darker, so it could be like 0.5 red, right? So now when the percent fills up, oh no, it's not doing that. Excuse me, I do want to come to the background image and make this 0.5 and then 0, 0. Well, I made a mistake on the fill color and opacity. I turned the alpha to 0. So let's turn the alpha back to 1 so it's actually visible. And then when I do my percent, now it looks like there's missing health, right? So that's the full percent. So just for debugging purposes, you want to leave a little here just to show that it's like that. And then we need to come to the graph and just get rid of these. And man, I don't want to make a new event graph. I want to make a new function. It's called set progress bar percent. And it should just take 2 floats. Current health and max health, and instead of progress bar, set health bar percent. And then this is a safe divide, current health by max health, get health bar and set percent, and set percent, and that should be fine. So what we're going to do is back in here, I'm going to add a widget component. I find this much easier to do in blueprints. This is the overhead bars. And the overhead bars, we're going to set it to screen space, and the widget class is an W enemy overhead bars and draw at desired size. And we set that in the event graph. On begin play, I'm going to make a function that's called spawn overhead bars. And in the overhead bars, I'm just going to drag it out here. Well, first I'm going to call create widget, and I'm going to set it to the enemy overhead bars, promote this to a variable called overhead bars widget. And in the overhead bars, I can call set widget, which is going to be this. And then in the overhead bars, or in the overhead bars widget, and then this is all what I'm going to really want to do. Back in this, I'm going to say spawn overhead bars. But the thing is I need to get off the AI what their health is, right? So I mean, I could say get attributes, because I have the get RPG attributes. Remember when we made this blueprint read only? And actually, if I wanted to, I can come back into the spawn overhead bars, and I could take the overhead bars widget and say set elf bar %, and I could get RPG attributes, and from here I could get health, and I could get max health. I split the pin struct on both of these, and then I say the current value of health and max health current value, and try to not make this look terrible. And I could set that, but the issue is that only sets that, right? We update it using delegates on the player, and we're going to do the same. We're going to do the same idea on the. We're going to do the same idea on the enemy. Excuse me. So on the enemy, well, on the player. Excuse me. On the player, I have bind callbacks to dependencies and then broadcast initial values. I don't really think I need the broadcast initial values yet, but for sure I'm going to want something on the enemy that's similar to bind callbacks to dependencies. So because of that, I'm going to come back on the character base, and in the protected section, I'm going to make it a virtual void bind callbacks to dependencies as a virtual function that I can generate the definition. And again, we're going to say intentionally left blank for now, right? And then back in the player, I need to take this out of the private section now, and I can come up in here and mark it as a virtual void and override. And now that I actually see this, I have init class defaults as well, don't I? So let's also make this a virtual void init class defaults. Blank for now. So now that we can do that, now we can take init virtual override and the enemy base. Override. Okay, so now these are all virtual void overrides, but in the enemy base, I need that last one, don't I? Virtual void bind callbacks to dependencies override. we're not going to call super, but we're going to do the same idea we want to do on the player. For now, I have the player's way of doing this events, and I really want to redo it later once we get a more established UI, right? Once I get into displaying the active abilities and ability slots and cooldowns and all that stuff, and I've got a more expansive UI, I'm going to refactor how I do these health bars for the players into a controller system instead, like the inventory. However, for now, we're just leaving it on these basic events, which means I need the basic events, right? Void on health changed, float current value, float max value, new function, blueprint, implementable event. And actually, if this is the case and we're sharing this, I could just delete it here, because on this case, I can literally just bring these now back to the public section of the character base for now. I could do that instead, and then I can just come into the enemy base and say if is valid, oh man, if is valid RPG ability system comp and is valid RPG attributes, then I could say RPG ability system comp, we can get gameplay attributes, get gameplay attribute value change delegate for the RPG attributes, get health attribute dot add lambda, capturing this is all I need to capture, and it's going to give me a const on attribute change data reference called data that I'm just going to say on health change data dot new value, and then the RPG attributes I could just say get max health. So now I have that. Now let's make sure I saved everything properly. Save all, and then recompile and reload the editor. Okay, so now we're back in the editor. I'm going to open this up, and I'm going to come back in the event graph. And now, because we're inheriting from all this stuff, I can say event health, event on health changed. And I have the overhead bars widget, and we're going to say if is valid. Always check your object references and blueprints. It's very important. Inside the editor, it just gives you this nice error log that just says, oh, attempted access none, and nothing happens. But it's the equivalent of trying to call a function on a null pointer, and it will just crash your engine. So in your game code, when you put it into a shipping build, it'll just crash. So anytime you use object references, just is valid, right? But we can say set health bar percent, because I'm getting the current health and I'm getting the max health. So what happens now if I hit go? Well, first off, that overhead bars widget is way down low, and on the server it's set to 0%. So we need to come back to the viewport. The overhead bars needs to be overhead. Let's start with that. And then the second thing is, let's check on begin play. Let's check on begin play in the set health bar percent. Let's put a breakpoint here, and then current health value 0 and 0. So it's not getting any health. He has no health. Okay, so we're getting the nothing, the 0, right? But at the same time, in the primary enemy, we're calling overhead bars widget to set percent, right? The issue is, however, if we do again like we did for the player, right? We could simply put a delay, and we can put Doesn't even have to be very long, 0.5 second delay. Then we do the same thing. Now his health is full, right? Now his health is full on both the server and the client. So everything's replicating and it's there. But we got another issue of there's just some latency, that there's just some timing that these things are established versus not. So I don't like leaving hacky delays in everywhere, but at the same time, I don't have a generic solution as of yet. I don't have a generic solution that I can put in this project that handles a better version of this delay concept right now. So after this, now at least you should have an enemy on the client, an enemy on the server, and we know their health is 100% at 100 and 100. So the next concept for the next video is going to be that we're going to make an ability that actually causes damage and can affect and deal damage to modify the attributes of everybody from clients, and it's all predicted and it's still replicated in server authoritative and everything like that. So I will catch you guys in the next episode.